Hi students, how are you? In the last two classes of the chapter sets, we discussed the basic and conceptual things such as definition of a set, different types of sets, the description of the set in different forms, that is roster form and set builder form, different operations between the sets, description of the sets through the Venn diagrams, and the relation between the cardinal number of the sets. Now in this class, let us discuss some problems. Are you ready? Okay, let us start now. Okay students, before starting discussing the problems, first let us see some basic concepts which are helpful for us in solving the problems. So the first one is, if x belongs to A implies x belongs to B, then we can say that A is a subset of the set B. Here x belongs to A. Element x can represent any element in the set A. So if you take any element in the set A and if this condition implies x belongs to B, it means whatever element you can take in the set A, if that element belongs to set B, we can conclude that A is a subset of B. So this condition is very useful to prove the laws of algebra of sets, such as A union B is equal to B union A, that is commutative law, or A minus of B union C is equal to A minus B intersection A minus C, that is De Morgan's law. Like this, here we can use this condition, this concept, to prove the laws of algebra of sets. That's why here we can say that if x belongs to A implies x belongs to B, then we can conclude that A is subset of B. So in the same way, suppose if x belongs to A by implies x belongs to B, what does it mean? Whatever element in A belongs to B and whatever element in B belongs to A, we can say that A is subset of B and B is subset of A. So by the equality of two sets, if two sets are subsets to each other, we can conclude that those two sets are equal. That's why if x belongs to A by implies x belongs to B, we can conclude that A is equal to B. This is another condition. Next, third one. X belongs to A union B implies x belongs to A or x belongs to B. This point we discussed at the time of union of two sets. So if any element is in the union of these two sets A and B, we can say that that element belongs to either A or to B, or it may belong to both the sets. That's why x belongs to A union B means x belongs to A or x belongs to B or x belongs to both. Of course here we need not write x belongs to both. Next, fourth one. X belongs to A intersection B. Intersection means this is the set of the elements which are common to both the sets A and B. That's why X is a common element for the sets A and B. That's why X belongs to A intersection B means X belongs to A and X belongs to B. So here you can observe, for the union we have to take the connective OR, and for the operation intersection we have to use the connective AND. So x belongs to A intersection B is nothing but x belongs to A and also x belongs to B. And next one, x belongs to A minus B. So A minus B is the set of all the elements which belong to A but not belong to B. That's why here whatever element you can take in the set A minus B, we can say that X belongs to first set A and X set does not belong to second set B. Next, another point. Suppose if you take any element in the set A, given set A, and if you find A complement for the set A, we can observe that this element can't be present in the set A complement, because A complement means set of all the elements which belong to universal set mu but not set A. That's why here if X belongs to A, definitely X does not belong to A complement. And also we can say that if you find complement of this set, that is A complement whole complement, again this element belongs to A complement whole complement. That's why here just you remember all these basic conditions. These conditions are very helpful for us to solve the problems in the chapter sets. Students, let us discuss the problems from the basic level. That's why here let us see the first one. The set A is equal to set of X such that X belongs to N and X square is less than or equal to 16 is a dash set. Here options null set, finite, infinite and singleton. So to decide the type of the set, first you have to write the given set in the roster form. That is also called list form. That's why here first let us list out the elements in the given set A. So what is the given set? The condition in the given set are X is a natural number. X belongs to here means X is a natural number and its square is less than or equal to 16. So what are the natural numbers whose squares are less than or equal to 16? That is 1, 2, 3 and 4, because 1 square is 1 which is less than 16. 2 square is 4 less than 16. 3 square 9 less than 16 and 4 square 16, that is equal to 16. That's why here we can say that the elements in the set A are 1, 2, 3 and 4. Now tell me, is it a null set? No. Is it a finite set? Yes, because there is a limited number of elements in the given set A. That's why we can say that it is a finite set. That's why option B is correct option. Okay, let us see the second one. B is equal to set of X such that X belongs to W and X square is equal to 25 is a dash set. Here some options are given. So here also first let us write the given set in the roster form. For that, first we have to take the given conditions related to set B. So what are the conditions? Here the element X is a whole number because it is given X belongs to W and whose square is 25. Of course, if you solve this equation, X square is equal to 25, so X can be taken as plus or minus 5. But here we can say that minus 5 does not belong to W, because generally we think that as X square is equal to 25, X can be plus or minus 5. So but here this set B can't contain two elements 5 and minus 5, because in the set B each and every element is a whole number. That's why we should not consider the element minus 5. So B is the set which contains only the element 5. As B contains only one element, we can say that it is a singleton set. Students, shall we do this problem now? Okay, let us see. Identify empty sets and singleton sets. Here these are the given sets. Now let us verify one by one. The first one, it is the set with no elements at all. But we know that a set with no elements is called an empty set. That's why it is an empty set. Next, this is the set of 5. But don't think that it is a null set, because it is the set with one element, that is 5. Here 5 is an element in the given set. As this set contains one element, we can say that the second set is a singleton set. Second set is a singleton set. Come to third one. Third one is also a set with only one element 0. That's why it is also a singleton set. And the fourth one, set with no elements, that is set of a null set. Here null set is an element. Null set is an element. That's why this is the set with one element 5. Same as second case. Of course, second case and fourth case both are equal. That's why it is also a singleton set. It is also a singleton set. Come to fifth one. Here this is the set of all the real numbers whose square is less than 0. Tell me students, if you square the real number, can you get any negative number? Never. The square of a real number is a non-negative number. That's why we can't find any real number whose square is less than 0. That's why it is a set with no elements. It is an empty set. Come to the last one. This is the set of all the real numbers whose square is less than or equal to 0. But we know that the square of the real number 0 is 0 itself. That's why this equation can be satisfied by the real number 0. So it is the set with only one element 0. That's why it is a singleton set. It is a singleton set. So like this we can decide whether the given set is an empty set or a singleton set. Students, shall we see this problem now? The set A minus B is equal to which of the following? That is B minus A intersection B, A union B complement, A intersection B complement. Here, to find out the equal set of the given one, we can use the element wise proof method. For that, we have to use the conditions that we have discussed in the beginning of this class. 6 points we have discussed. So we can use those conditions. For that, first we have to consider the element x in the given set A minus B. Here, the element x represents any element in the set A minus B. Now, by the definition of the difference of two sets, we can define this one as x belongs to A and x does not belong to B. It by implies that x belongs to A and here x does not belong to set B. But one of those 6 points is, if x belongs to A, then x does not belong to A complement. Again it belongs to its complement. By using that condition, here we can say that as x does not belong to B, we can say that x belongs to its complement. That's why we can write the condition that x belongs to B complement. Now x is an element which is in both the sets A and B complement. As the element x belongs to both the sets A and B complement, we can say that the element X belongs to their intersection. So it by implies that X belongs to A intersection B complement. Here we have taken one element X in the set A minus B, and now we have proved that the same element X belongs to A intersection B complement also. And also here we have used by implies. It means every element of A minus B is present in A intersection B complement, and also every element of A intersection B complement is present in the set A minus B. That's why we can say that these two sets are equal sets. Therefore, A minus B is equal to A intersection B complement. That's why option D is the correct option. Students, shall we see this problem now? For any two sets A and B, A minus of A minus B is equal to B, A union B, A intersection B, A minus B. So here also, to find out its equal set, we have to follow element wise proof method. That's why first let us take an element X in the given set A minus of A minus B. Now we can describe this element as X belongs to first set A and X set does not belong to A minus B by the definition of difference of two sets. It by implies that X belongs to A and X set does not belong to. In the previous question we have proved that A minus B is equal to A intersection B complement. So let us replace this set by its equal set A intersection B complement, because A minus B is nothing but A intersection B complement. Now it by implies that X belongs to A, and here you see X set does not belong to A or X set does not belong to B complement. Actually the operation intersection will give the connective AND, but in the negative sense intersection will give the connective OR, and in the same way union will give AND in the negative sense. That's why as it is X set does not belong to A intersection B complement, we have to describe this situation as X set does not belong to first set A or X set does not belong to second set B complement. By implies X belongs to A and X set does not belong to A, or here let us see X set does not belong to B complement. As X set does not belong to B complement, we can say that it must belong to B. So X belongs to B. Here this is the conjunction of these two sets. In this, the first statement is X belongs to A, that is confirmed, and the second statement X does not belong to A or X belongs to B. As already we have got that X belongs to A, here we can say that X does not belong to A is wrong. That's why of these two conditions X belongs to B is correct condition. So we can write it as X belongs to A and X belongs to B. It by implies that X belongs to A intersection B, because it belongs to both the sets A and B. That's why the element X must belong to their intersection. That's why X belongs to A intersection B. So here also we have taken one element in the given set A minus of A minus B, and we have proved that that element belongs to A intersection B. And also here we have applied by implies. That's why whatever element you can take in the set A intersection B, we can say that that element X belongs to A minus of A minus B. So we can say that A minus of A minus B is equal to A intersection B. So option C is the correct option. Students, now let us see this problem. If A is subset of B, n of A is equal to 25 and n of B is equal to 30. Then n of A union B. Here, in the question itself, one relation is given between the sets A and B, that is A is a subset of the set B. When one set is a subset of the other set, there are some conditions. Remember students, if you want to find union of these two sets, you will get superset as a result. If you want to find intersection of these two sets, you will get subset as a result. If you want to find A minus B, you will get null set. So these are the some conditions that you have to remember. Now in this question, we have to find now the cardinal number of the set A union B. But already we have seen these results. So in this condition, A union B is equal to B only. That's why n of B is equal to 30. So option C is correct option. Students, let us see this problem also. If A and B are two sets and n of mu is equal to 800, n of A is equal to 500, n of B is equal to 100 and n of A intersection B is equal to 75, then n of A complement intersection B complement is, here we have to find the cardinal number of the sets A complement intersection B complement. But by the De Morgan's law, we can write A complement intersection B complement as n of A union B whole complement. But A union B whole complement can be written as mu minus of A union B, mu minus of A union B. It can be written as n of mu minus n of A union B. N of mu is given in the question itself. Now we have to calculate the cardinal number of the set A union B. But we know the formula for cardinal number of the set A union B, that is n of A plus n of B minus n of A intersection B. What is n of A? That is 500 plus n of B, which is 100, minus n of A intersection B, that is 75. If you simplify this one, you will get 525. This is n of A union B. As we know n of A union B, we can easily find the cardinal number of the set A complement intersection B complement. That is n of A complement intersection B complement is equal to n of mu, that is 800 minus 525, which is equal to 275. That is option C is correct option. Okay students, these are the problems that we have discussed in this class. In the next class, let us discuss some more problems.